What's new? Well, that's a question we all ask and want to know about and see what's going on. So I'm really happy to have Rich Redmond with us today from Broadcast Electronics. And Rich is going to tackle the topic of what's new in transmitters and some of the other things that BE has been doing lately. Rich?
Well, thanks, Barry. And yeah, you're spot on heat. The good news is over time, there's a lot of things in electronics, especially RF devices, that have allowed us to extract more heat from things a bit more easily. But it it's still a killer. Um, if you don't get the heat out, they generally don't last very long. Can you guys see a screen?
Yes, sir.
So, intent was just going to kind of talk a little bit about, trends in technology and how they impact transmitters, and also kind of how transmitters are becoming a bit more than just the device that turns audio into RF or audio and video into RF if it was television. And a lot of thanks to Perry. He helped quite a bit with all the content that we've got here. So, bit of a team effort. Um, so I think broadcast electronics been around for a long time. We build radio and TV transmitters from low power to high power. And also, you may think of us for studio products like Audio Vault or TRE or metadata, of course, HD radio, DRM plus. Uh, I did get asked the question by a group engineer one day when I was in Quincy. He said, "Are you in Larry Cervone's office?" And I said, "Well, no, I'm actually pretty close, but I think it was one down." And indeed, when you go to the breaker panel in the front office, it has listed the names of all the original recipients. So um, at least the office I'm in was on the same circuit breaker that was Larry's. So uh, look, if I think of radio engineering skills that we're up against and how they impact, transmitter technology, you know, uh, in the past, evolution of technology was a bit slower. You could learn a skill, and for some guys, those same specific skills would be, usable across your entire career. Certainly in our industry, RF skills were some of the most dominant. Everything was hardware focused, and troubleshooting was done down to the component level, and work was done in the field. Today the evolution of technology is much faster. There are skills that at one time were critical that now don't have any impact. Um, I had to explain to my 22-year-old daughter that tube amplifiers were not a new thing, that she had discovered that indeed they had been around for a while. Um, and so that impacts the technology that we develop. When we think around the operational environmental environments that we're working in, radio broadcasters and TV broadcasters, the only way we delivered content was over the air. Today, we've got a lot of different platforms. I benchmarked and went back to the mid 60s and was thinking of an AM FM radio station. By comparison, labor costs were much lower, but the cost of hardware was much higher. So in 1965, you could buy a 1 kilowatt transmitter for about $7,500, or in today's dollars, about 72,000. By comparison, most 1 kilowatt FM transmitters today, solid state, will be $7,000 or less. Um, and the cost of high quality engineering skills have gone up. Energy costs are higher, both in absolute dollars, but as a percentage, and real estate costs have become a bigger deal. So, that impacts how much space we allocate to transmitter sites. And do I keep fixing something that's been around for a long time, or do I replace it? If I have really high engineering costs, I need them to be really efficient and swap out parts, or I need to be able to replace. Now, Barry mentioned heat. So at the core of everything we do is generally some sort of RF device. And in the recent past, these have had a lot of changes where, we've now pretty much everything is using LDMOS devices. these have tremendous advantages. One, along the heat line, the thermal efficiency is much, much higher, so there's less resistance. So the ability to get heat out and keep the junction temperature lower is much easier. Also, they have a lot higher gain, so we end up not having to need many stages in a transmitter where, 10, 15, 20 years ago, we would have lower gain of the amplifier devices, so we would have to have an exciter with maybe 10 to 50 watts, an IPA that might, put out 500 or 600 watts. And then we might have, 30 or 40 devices to get 10 kilowatt FM transmitter. Today, we need drive levels for 10 kilowatts that are less than, 10 watts. There's no IPA. And in some designs, you can have, less than 10 RF devices to make 10 kilowatts. So pretty big change because of these devices. And it's really driven by the 5G and base station market. Switch mode power supplies aren't just for computers and haven't been for a long time, but probably the biggest innovation is the cost per watt goes way down. Efficiency is very, very high, some approaching 98% efficient, so very little waste. They almost all have adaption so that you provide a good load to the power line. So they're quite efficient from that standpoint as well. And because they provide automatic regulation, the ideas of thinking that I need an automatic voltage regulator to deal with the fluctuation in power, even at the top of the mountain, have been eliminated. So not only did the power supplies themselves get more efficient, because of the built-in automatic voltage regulation, I get rid of a whole bunch of other steps in the process. So that's really quite good. And then, of course, at the exciter level, we've gone from analog based modulation in TV and radio to digital based modulation. And I don't necessarily mean that it's a digital waveform like HD radio or ATSC 1 or 3, but just that the genesis of making it goes from analog components to being done in an FPGA. So these shrink down the component cost and it makes it very replicatable. So the good news is generally if I'm making good quality audio signal, I have an awful lot less to drift and adjust. So it really lowers the maintenance cost. Today, the demands for control and monitoring are far different. We used to wire up a lot of parallel things to a remote control. And then we got excited when we could talk on a telephone with it. Now almost every device has an Ethernet jack and has SNMP capability. And this ties a lot to the migration of skills in the marketplace as they become more IT oriented. So we take all of those and we think about, how does that impact transmitter development? So for sure, lots of the other manufacturers, we all kind of think about the same kinds of things. At BE, we've implemented a new product that we started shipping this past fall called the ETX. We basically took a lot of what we'd be doing in the STX transmitter that we've been making for quite some time. And then we took some capabilities from the Italian company we've been involved with, Elenos, that had some compact low power transmitters and kind of merged them together to get something that brings quite a bit of capabilities into one box. Now, well, I'm not going to go super in depth on, exactly what the bits are inside. I think some of the keys are uh, space consideration. Everything gets a lot smaller. Transmitters now come with, as we can talk about, built-in LAN interfaces, with Ethernet, the ability to have serviceability, removable fans from the back panel. So if you have a failure, you don't even need to take it out of the rack or even take it out of service. Hot pluggable power supplies from the front, so you don't need to open it up. But remarkably, the footprint gets really small. So 5 kilowatts is in 4 rack units, and 600 watts to 2 kilowatts are in 3 rack units. That's exciter, amplifiers, power supplies, everything. And when you start stacking them up, we can do 30 kilowatts in a single rack, which is incredibly space efficient. So when we get back to that thing of, what was once just a single FM transmitter site now has three or four stations on it and a bunch of translators, or TV and radio are together. The footprint is really shrinking. We have a lot of guys who take out, a fairly common tube rig. Like if you look at, uh, even not very old, like if you look at an FM30T or 35T that we delivered from BE or the A or B series, in the space that one 30 kilowatt transmitter fit, you can put 3 to 4 30 kilowatt solid state transmitters today. And so it's not just that a 10 kilowatt transmitter fits in a handful of rack units, it's that, 430 kilowatt transmitters fit where one was. Now, for sure, a lot of that's around amplifiers and power supplies, but even more so, it's the consolidation of these other capabilities shrink down to software and what chips are available. So if we look at the digital modulator card, things like all of these inputs and input switching. I don't have to have an outboard switcher. I can take uh, IP sources directly in, whether it be codecs or AES67. I can take, normal composite. I can take left and right. I can take AES. If I'm a translator, I can even have a built-in HD radio receiver. So I can rebroadcast an FM, or I can pick up an HD2 and rebroadcast it. And we have the ability to tie into satellite receivers as well. But so it's packing a lot of these different separate boxes that today we don't need a separate power supply. We don't need to have separate user interfaces into the same spot. And so this continues with other things like, a stereo generator and RDS generator and a transmitter. They've been around for a little bit. And those are seen as pretty straightforward, but there's a little bit more audio manipulation that we're able to do, as well as all of this remote telemetry. So some things that shrink down in our case here, as I mentioned, we're pretty unique in that we have an FM or FMHD card that can go inside. Now you could either use that for off-air monitoring, or you can use it in like a translator mode. And the repeater also has RDS regeneration, which is, pretty handy. We've got the ability to do auto switchover. A lot of times we tried to come up with backups at the transmitter site. Well, we can take an SD card, and that's an option you can get that allows you to play out a playlist if you lost your STL, for example. Uh, for those that are Optimod 8100 fans, you know, the idea of having a zero card in the Optimod, which originally was designed to get rid of trash that went in the subcarrier region back when you had Muzak, or maybe, I don't know, you had the Korean language format. But then people quickly figured out, oh, that actually is kind of a loudness device. I can get a bit more loudness with the zero card. Well, because we have the digital modulator, we're able to do another thing. We call it the soft clipper, but really it's a filter. So it takes information that might have ended up from your audio processor from clipping or other such things that kind of ends up in the higher order frequencies. It can kind of roll that off and clean up that portion of the waveform. So that's standard. You can turn it on and turn it off. It does provide some nice loudness enhancement without really distorting anything. Now, for years, we've all had our own favorite flavor of audio processor. And of course, when I mentioned the audio inputs we do that as well. But in a lot of transmitters today, you're starting to see uh, the consolidation of things like software-based audio processors. We do one with Stereo Tool, and we also support micro MPX. So in this case, I can put the processor in the transmitter, or if I want to use one of the normal processors that also has micro MPX, I can feed the STL directly into the transmitter without a separate outboard codec. So these are some pretty cost-effective options. But in addition to saving you money, they also get back to that shrinking the footprint down so that you get a lot more capability in smaller space. It's all available through the browser. Now, again, look, if you don't have to use Stereo Tool, it's a nice option. We know everybody has their favorite flavor of processing, but where this can be really interesting and cost effective is, Say I'm distributing, I might be a state public network and I'm distributing, or a religious network, I'm distributing a lot of content over satellite and I'm sending left and right. Well, instead of having to buy a separate audio processor at every site to create my stereo and clipping and so forth, I can just have some software inside. As I mentioned, built-in RDS encoder. I don't need to have that outward anymore, and it can take a feed in to do dynamic RDS if you want to do that. Power efficiency, heat all comes from inefficiency. We're 76% AC to RF efficiency, so very, very good. In the top tier of the market. And just to kind of put that in numbers, today a 5 kilowatt transmitter consumes just under 6.6 kilowatts, where a lot of them on the market and things we built in the past, it was almost a kilowatt higher. So you take that from waste heat that you had to cool or makes the room even hotter in August, or paying for the bills, uh, all of that kind of adds up. Now, one thing that is a little unique, I mentioned whether you just want to listen to the audio input sources or you want to listen to that receiver that's inside, we actually have an audio monitor. If you want that option, you can plug the headphones right in the front, which again, I don't need to have a separate rack mount tuner or other device. Things like a USB port, especially if I want to have a backup transmitter on the shelf that I take around, I can put all the configurations on a thumb drive and I can upload it based on the site and save all of those. So it's good for rapid deployment, or if I have a bunch of them that I want to copy paste, so to speak, all the settings that I worked up, with, like, say, notifications and all that, it all can be done inside. We mentioned telemetry, and I was talking a lot about the interface with uh, HTML. You don't buy a $29 Linksys router without having a web page in it that you can set up. And so everybody expects that I have those capabilities, and transmitters are no different. And you don't just have a really big one to do that. So, we have HTML web GUIs with security, and there's a full SNMP MIB. The other thing that's a little unique here is we have the ability to put in an LTE 5G modem inside the transmitter, so that if you're in a place like maybe you're feeding with satellite or off the air and it doesn't have other services, uh, this can all go inside the transmitter and provide connectivity. Now, again, you can use outboard services like, Max Connect or other such things. There's plenty of, wireless modems. But if you'd like to have everything integrated, we certainly do have that. And there's also a little UPS that can back the modem up. Web browser setup is pretty straightforward and allows you to decide on the inputs and provide some information. It's all HTML, so it works on a normal screen. You get fault logs that tell you, and in the faults, you're able to decide, if I have reflective overpower, for example, it's lighting up a LED, it's hitting the log, it, could do email or SMS or traps or relays. It can do all of these kinds of things, and you can set alarms or warnings depending upon the severity. Um, Again, that more, GUI setup, pretty straightforward. Now, not to be left out in AM, um, we recently brought a new user interface, which includes web-based control to the BEAM products. The thing that's a little unique here is we designed this to be retrofittable to all of the BE products in the field. So if you've got an AM1A or an AM10A from, 10, 15 plus years ago, no problem. We can swap out the front panel door, which gives you a similar annunciator panel and power levels, a similar set of bar graphs, but instead of being dedicated LEDs, we have it on a selectable screen, which is able to capture forward and reflected in a number of other settings. There's HTML GUI, which you can pick a dark or light mode to, which not only replicates the front panel and has some tabs for, there's an event log and different modes, IP setup and so forth, as well as firmware updates can be done remotely. Uh, But in addition, there's a full fault log that keeps track of the last 100 events that happened in the transmitter. And then we also included a power schedule. So if you need to go, day power, night power, for sure you can always do it with the remote control. But if you're at a site where maybe your remote control doesn't do that, or you're doing your remote control just via the web browser or whatever, that capability is built in. So this idea that for a long time, we always thought the ability to control our transmitters was a separate box's responsibility. And as transmitter manufacturers, we still have parallel controls because people have that, but having a built-in web GUI is kind of a cost of entry these days. But on the AMs, we also wanted to make something that was backwards compatible so that guys who are using a reliable 5, 10, whatever year old transmitter, um, could get those capabilities without having to say, geez, to get the web GUI, I need to spend 50 grand to get a new transmitter. So those are some of the trends. I mean, I'm happy to take questions, and I'm sure Perry would be happy to answer any as well if any of that's helpful. But I think the high level point is, look, there's a lot of things changing in our environment. The development of new products reflects the markets they're used in. We all try to be conscious of the cost to operate, and the number one thing there is electricity. We're trying to be conscious of making them easy and smaller to install, and that fixing them, we realize, you know, very few people are component troubleshooting at the transmitter site. So things need to be modular, small, and easy to swap out and get back on the air. And that you need to look at everything through a browser because, look, as we're all spread much thinner, driving 150 miles round trip to go to the front and just press a reset button uh, is inefficient, and that's probably the polite word. So anyway, Barry, I'm happy to take any questions and chat with anyone uh, or any that you may have.
Well, I'm certainly interested in seeing these new models, the ETG. I, we all remember when a 1 kilowatt transmitter was as tall as a man and maybe 5 cabinets wide. And then Nortel came out with the one that you could put on a tabletop. Now it's 3 rack units, as you say. So one of the questions that I would have is heat issue within the transmitter itself.
Yeah, that's a great question. So, part of like if you take FM, for example, um, like if you go back in time, tube transmitters reasonably efficient even at 1 kilowatt, but you had a real high volume blower blowing a ton of air across the fins, and you had a high voltage power supply and all this stuff that was radiating heat. So the power supply itself, not incredibly efficient. Tube, somewhat efficient, but together, you might be lucky to get 50% efficiency out of an FM transmitter, AC to RF. Um, Fast forward to today, power supplies, AC to DC efficiency well above 90% in almost all of them. The ones we use are, I think, 96% efficient. So, geez, you got 4% of heat going there. And then you go to the RF amplifiers. So to get to 76% overall, and I should point that out, that's AC and RF out because a lot of times, and I did this like, oh, geez, my FM 2.5 H3 in, 1978, yeah, my efficiency was like 72%. It's like, well, right, but that was the PA efficiency when I did the indirect method. So today, if I'm 76%, that means power supplies are really high efficiency and that the amplifier, so the DC to RF efficiency is going to be in the mid 80s, right? And then this other point I made about thermal impedance is important because uh, getting the heat away from the junction, so junction temperatures can run a lot higher than they used to be. RF devices have been made what they called ruggedized, so they're more impervious to reflected power, they're more impervious to power spikes. They've just become more robust over time. And that includes their tolerance to heat. But the ability to get the heat out into the heat sink then allows you with air, to evacuate it pretty quickly. So, um, I would say all those advances are part of how it got smaller, Barry. So not only did the devices and stuff get smaller, um, but what's not always so obvious, we talk about the device efficiency, uh, but I may only have one RF device in a 1 kilowatt transmitter today. Like if you went back and you said, my STX, uh, 1LP transmitter, there are four RF devices in the output section. Um, when I was at Gates, a 1 kilowatt transmitter, we had two smaller devices, two 600-watt devices, but they were even Gemini package devices. So in essence, they were, four devices. Today, Gemini package device, one device, but kind of two halves to it. And you go back even further in time, geez, there were a lot more, right? So not only is there less, but it gets rid of all the combining inefficiency because we used to burn off a lot of power between the splitter and the combiner to split the drive to the X number of devices and to recombine everything. So these devices becoming more powerful, not just are they efficient in their own right, but they allow us to get rid of a lot of passive RF components that burned up efficiency. So it probably really long answer to your question, but there's a lot of things that drive why we're able to do it now and not be unreliable.
Yes, well, I wanted you to bring that out because some of the earlier transmitters, well, let's say middle range solid state transmitters did have that heat problem for some of the reasons you just mentioned. And I like the idea you had four fans there that can be maintained without turning it off and opening the box. That's good.
Yeah, yeah, because you think about it, right? I mean, uh, look, a super high quality engineer may be available for almost every station, but he may be 100 miles away. And you may have someone who's uh, that person can walk through changing something with a little bit of guidance and, using, FaceTime on an iPhone without getting him into trouble, but they don't even have to open the box, right? So it's easier if a high skilled engineer shows up, but it's also something that someone can be coached through some of these things in a pinch, and it just makes maintenance. Same with swapping the power supplies. It just kind of helps deal with the environment we're all in a little bit better.
Yeah, and you can know before you get to the site a lot more than you used to be able to do so. I see Harold's got his hand up, and I'm going to turn to him, but I'll just make one little nudge. You showed the change in pricing from the transmitter from
Yeah.
7,000 to
Oh, yeah, yeah, yeah.
70,000 to 7,000. It's funny when you look at the engineer that was making 7,000 in 1965. He's making less now with the
Oh, yeah, yeah, yeah. It was not, you know, for sure, Moore's law has driven the cost of technology down at a far more rapid pace than the cost of wages have gone up.
yeah.
But yeah, yeah, it's not reciprocal exactly.
I just thought it was just very interesting. It was sort of almost a swap back and forth. So, Harold, what's going on in your head?
Very interesting subject here on cooling. What I really like to see is a sealed box, pretty much with conduction out to a heat sink, and then the air blows the stuff blows over the heat sink, rather than turning the box into a vacuum cleaner that I have to go in and clean out. Had to do that was my job in the 1970s and 80s, was vacuuming out transmitters in the middle of the night, and it's nice to avoid that. On manufacturing costs, I think that automated assembly and the smaller box is what has managed to keep the costs down. That those old tube transmitters, that was all hand assembly, and now with automated surface mount assembly, it's really gone down. On FM, direct digital synthesis is amazing. I first read about it in the 1970s. It was a magazine article that said you get a latch, a full adder, a signed lookup table, and a D to A, and you can make any frequency you want. And recently I've done that for audio in 2 lines of code in C. It's really amazing. Then finally on AM, I know BE has a patent on a H-bridge circuit for envelope modulation. And looking recently at some of the manuals for your transmitters, they're all PDM. I think at one time you did make an H-bridge AM transmitter. And I think that it'd be interesting to combine that concept along with Kahn's 1950 envelope extraction and reinsertion idea. And then under DSP, you could generate any RF waveform you wanted. So those are my comments.
Oh, interesting. Thank you. Yeah, you know, your comment on the airflow is pretty good. The one of the things that we've tried to do is have most of the airflow over the heat sink rather than components. And we also generally these days try to have the combining balance as strip line that are on the PC board, so they're directly attached to the heat sink rather than cables that are loops that are requiring airflow over it. Because if you can, like you said, move most of your airflow across the heat sink, uh, then that allows you to keep a debris from accumulating on the circuit boards.
I think part of it too is the modern transmitter site ought to be a little more attentive to having outside dust and such blocked before it gets in the first place.
Well, for sure. Now, you know, on the grill, by the way, when we had that chrome grill there, there is actually a removable washable filter there. So we do try to, you know, head start that. Now, to your point, if you, which I think you started with, Barry, about cleaning filters, if you ignore the filters, it's also an excellent tool at blocking all the airflow, and you'll certainly have a power shutdown.
True. Brian Black puts in the chat box, digital meters on the AM transmitter is probably a good idea. The analog meters seem to always get stuck.
Yeah, you know, it's one of those things that when you first design something, you know, you use what's at hand and you use what people expect. And analog meters were plentiful, and you know, everybody used them. But what we found over time is people have failures in the field. You know, mechanically those meters break, and then it's honestly harder for us to get, you know, a good source of meters going forward. And the other thing that was a little funky was um, both said that there are 2 meters in the transmitter, one with a selector. Uh, they were both actually different scales, and they were different in every single model. So it's like the 500, the 1, the 2.5, 5, 6, and 10 all had a different complements of meters. So inevitably, when a customer had an issue, the one that they needed was the one that we had just used the last one of. And the one that we had, you know, 25 on the shelf was not the problem. So by doing it digitally, you know, there's a little switch that you just set the board to which transmitter it's in, and you know, you kind of go to town.
Well, it's good, especially for if you have several transmitters and it reduces the parts that you have on stock or to repair.
Yeah, for sure, it does make it a lot simpler, and you know, it's fairly straightforward.
I'm going to ask this question, and I hope that you can just give us a 30-second or a minute discussion about the separation from broadcast electronics and LNOs. And is that one of the reasons the QB, the quick block, is less part of what you thought?
Yeah, so that's a good question. You know, so back in, like, I think it was 2018, you know, Elenos bought BE, and in some ways, um, you know, didn't do a totally full integration. You know, BE's kind of always been uh, a bit separate and had some separate products. Now, for sure, we sold Elenos transmitters here in the US. And, I think part of the go forward plan was that, Quick Block was this platform that could address radio and TV and so forth. Is the guys in Italy kind of ran into some struggle. Um, we slowed down on, when Quick Block's coming to market. And by the way, as such, being owned by Elenos, we didn't spend an awful lot of time in new product development at BE because it was kind of, driven from, hey, there's this new platform that's being invested in. So they kind of had some challenges. We had to pivot and, so that's where we went with ETX. And I think what long term you'll end up seeing, it's still kind of an evolution, but we think we've got a good road way to get, BE back as a US owned company. And, probably the Quick Block intellectual property will come this way. And, and then we'll finish that development and bring it to market.
Okay. Anyone that has a question, please feel free
It's a
to.
very clever design. And I think, it delivers a lot of value. Uh, Perhaps it was a case of the eyes were too big for the stomach on the development front.
Came a little fast, maybe.
Yeah, and I think probably the other challenge, like anything, is just, uh,
Getting folks used to doing it a different way.
yeah, cultures. Look, you get any six of us here on the phone in the room and ask them the best way to build a transmitter site. Uh, we'd be lucky if we had three of the same ideas that were in common. Because not that they're wrong, everybody's got a different way based on their experiences, right? And it's a little bit like herding cats to develop a new product, even when you just have engineers who all come from similar backgrounds and they're all working, 3 feet apart. We used to joke in other places that somehow where I live in Cincinnati and Quincy, Illinois, despite being 400 miles apart, you would have thought it was on the other side of the planet because getting engineers in two locations to agree became difficult. So when you put an ocean and 6 or 7 hour time difference in between, everybody gets pretty passionate, and sometimes it's a little bit slower to get things done than you would anticipate.
John posts here in the chat box, his retrofit request would be for more than 5 power levels to handle the multiple PSSA powers, and he's using a 2003 AM6A.
Okay. Well, so some of the power levels are set in the current control board. So while on the front panel browser, we're able to call up certain power levels, I'll have to go ask and find out if we have software control on that, because in the traditional transmitter, there are trim pots that get set for each of the power levels in the cals. Now, potentially there's a way to do more than that, but I'm not certain. So I'll go ask. Thanks. That's a good point. When you say more, John, I think you said it was John. How many did you say? Maybe you said and I just didn't catch it.
He says he used all 5 power levels and could use a couple more.
Oh, okay. So like, 7 or 8. Okay. Uh, yeah, we'll see how possible that is.
Oh, yeah, thank you. Yeah, this is John here. I was the one who raised that, especially now that they've come out with the new revised, improved PSSA levels that can break it down more granularly. If you're trying to squeeze every tenth of a dB carrier out, it would having 7 or 8 power levels would let us take more advantage of things.
Right. Uh, yeah, so I think the thing we'll have to take a look at. Yeah, so in your case, uh, you would need them to switch at a specific period of time, right? Like at 2 o'clock, or well, probably wouldn't be two, but like 4 or 5, so around sunrise and sunset, you're going to have step up and step down, like in critical hours.
Yes. Well, or in my case, I'm worrying about immediately after sunset. But yes, for those stationed with critical hours would be another example, or
Yeah.
sunrise.
Okay. Yeah, I can take a look. I know that we have, the setup around 5 is there, but I guess I'll have to look with the new front panel board in the software, because probably it might be a case of simply setting a target, and it's a routine between the power raise lower command and monitoring the forward power and, a target to trim to versus picking a preset, meaning it's a different way to get you to the same thing. So I'll ask. Thanks. That's a good thought.
Okay. Any more questions? Press your space bar, alternate A, or raise your hand and let me know if you're one of the bunch over there on YouTube. There is a little chat box that you can put a question in and I'll relay it.
Hey,
I'll,
Barry.
oops, go ahead.
Okay, one quick question. So, in early or earlier generations of solid state transmitters, the other thing that was of concern was, performance, like if there's an electrical storm or static protection. Are these new more rugged devices more uh, built better to perform when there's, an electrical storm outside or that kind of environment?
Yeah, that's a great question. So one of the things that, as much as I'd love to say it was broadcast innovation, but came from the base station market, is exactly that. So you've got all these, you know, LTE base stations at the end of a 300-foot tower along, the interstate, and it's in this box that sits outside. And so what came on the devices, so a device usually blows up around a few things. We talked about heat before. One can be overdrive. You can, avalanche a transmitter and blow up all the devices with a fast overdrive. So the new devices have some overdrive protection in it. The other thing will be on the output. Not only is there VISWAR, both, so VISWAR in a slow term, generally a transmitter, we've had proportional foldback on transmitters back to the tube days, right? But that's a fairly slow response. So the critical thing that the ruggedized devices have done is have substantially increased the amount of VISWAR the device can support instantaneously, and also it's at the different phase angles. So what sometimes would happen is you would do all your work and your protection would be around the carrier, and you'd have stuff that would come in at different phase angles because you had a reflection or something. So yeah, for sure. Um, this, I would say, it's 10 or 15 times more robust than some of the previous generations. There's a specific number. I don't remember it off the top of my head, Ed, but yeah, it's a lot harder to blow these up, a lot harder.
Okay, thank you.
I remember years ago that uh, here on the desert, we get a lot of that in the dry season where lightning strike will hit or uh, static electricity will build up. And it becomes important to have everything, if you're on AM, to have the ball gap set right. Uh, it's a whole system, but to hear that it's more rugged from the standpoint of design, that's always a good thing.
Yeah, and in fact, guys who are really interested, you can go to Amplion or NXP's websites, and you can look for devices that are ruggedized, and it'll talk about, a whole series of them. And it's because these same devices that we use in broadcast. So I mentioned like base stations. Well, that's a pretty obvious one. But also industrial applications. So you think of radar, well, that's a pulsed application. So you're constantly pulsing the thing on and off versus constant wave like we generally do in FM. You think of some of these RF heating and some of these other industrial applications. Uh, they're in a much more difficult environment than some of the applications that we're in. So um, the fact that they made the actual device itself, in addition to all the things we try to do in the transmitter to make it more reliable, but the device itself is far more robust. The idea of blowing up FETs becomes less frequent than what we used to see. So
But
it's a great question.
okay, Harold.
Yes, on static, I was recently reading an article on guideline insulator arc over and due to static buildup. I was wondering, first off, if there are any resistive guy insulators that would slowly discharge that, if that's an issue, or if that would not be the issue or would not be a fix. And then also, is the future of AM all PDM modulation, or is there anything with that previously mentioned H bridge that BE has the patent on?
Yeah, that's a good question. So, uh, there have been really two successful deployments of technology. PDMs, of course, the most famous, um, and and then the pulse step modulation, which showed up in the Harris DX first. So both of those, we kind of have Hilmer Swanson to thank for that. Um, the outphasing design that BE did in the 4MX was unique, but not broadly successful. So I think what you'll see from us is uh, as we migrate to newer generations of lower power transmitters, PDM becomes uh, really the most practical, because if you look at the other approach, which is very, very good at higher powers, the pulse step modulation, or they refer to it as like the DX modulation that was invented at Harris. You have to have a lot of amplifiers that you turn on and off in that. So, like if you've got a 50 kilowatt, like a 3DX50, I think there's 64 amplifiers in big and little steps that you digitize the audio and then you turn them on and off to make the waveform. And so when you're going up in power level, that works pretty well. But when you try to step down to 10, um, what happens is you need way more amplifiers to get the resolution to make the waveform than you actually need to make the power. So it's kind of almost like all these advances in bigger and bigger RF devices kind of go in the opposite direction of using some of these other modulation schemes. Where in PDM, uh, you now just have a bigger RF amplifier, maybe one device gets you 5 kilowatts, and then you've got a big, a PDM controlled power supply segment of that in the amplifier. So that's kind of why you see PDM, is because at the power levels where we have the most number of transmitters in the world, not necessarily the most number of watts, but most number of transmitters at like 10 kilowatts and below. Even today, it's probably the most efficient way to build a transmitter. Now, for sure, building one today versus one that was built in the past, the number of RF devices you would need to build a 10 kilowatt PDM transmitter, you know, would be a handful compared to a lot more in the past. Um, but I think what you'll see from us will be PDM probably is valid, certainly at 5, maybe at 10 kilowatts. Um, and then, probably at 50 and above, we'll be taking another look at the pulse step modulation, which is a pretty good technology for that power level. Oh, did that answer your question, Harold?
Yeah, I had not recently thought of the pulse step. I did work on one of those at a station, and hadn't thought about it in a long time. The outphasing, I thought what was very clever about the H bridge was the use of square waves on both sides of the H bridge, and then it's also interesting to compare that to ampliphase. But is there just disadvantages to that? I like the cleverness of it. I have not tried to build one though.
Yeah, that's a good question. I would say, my colleague Tim Hardy, who invented pretty much all the AM transmitters in the past 25 years at Nautel, um, works with us at BE. And, his belief was that while that was a clever approach, the implementation to be reliable was a bit challenging. And so he believes with today's DSP control, the pulse step modulation is probably a more practical high power implementation. Um, and on the PDM, I think similarly, the fact that we've got DSP control, we can now achieve some things today that when the outphasing approach was implemented, um, it just wasn't practical. So, today's PDM can get, both very efficient and very good audio quality. One of the things that's a little different on the BE implementation, even in our current product, is, and I think I saw in the notes somebody commented about how the transmitter can sound very good at low power, like a 6A, I think it said ran at 25 watts. So one thing that's quite different is that BE uses a regulated power supply and then changes the duty cycle of the power supply to run at low power, where most PDM transmitters have a fixed transformer based power supply and then change the duty cycle of the modulator to get the power down. But when you do that, even using digital capabilities, uh, you end up losing audio resolution. So you get poor audio performance at low power because you're kind of at one end of the range. So even that's why even like, look, the AM 1 to up to 10A series has been around for quite a while, but it still actually has excellent audio performance because it's unique in that it's regulated switch mode power supplies and that the modulator control only controls the modulation and power levels are controlled by changing the power supply settings, not by trying to use the modulator as a power control, which all the other designs on the market, that's kind of what they do.
Thank you very much. It's, great answers. And since the power supply is also PDM, it's sort of a cascaded PDM, one handling the power, the other handling the modulation.
Yeah, that's right. So, when you look at it, it looks if you compared two of the designs, at first you'd kind of go, geez, why is this? But then when you kind of understand this desire, especially for, some of the directional stations, or I guess omnidirectional that need to run at low power, you know, the problem it was originally trying to solve was that you could never get, a transmitter to run very well at low power. So we used to have those Contronics cutback kits, right, where you burned off a bunch of power and, some of these other things that we were able to solve. But the I guess I would say the end result was we were actually able to have very, very good audio performance, even to today.
One question that occurs that I think probably should ask is, you mentioned the efficiency, 76% on the FMs. Uh, is it similar on the AMs now?
Yeah, so it depends. Now, we offered a new product at NAB last year called MDCL Plus. So as you know, in the United States, stations are able to use modulation dependent carrier level control. And in that case, Barry, you're able to get, even lower power consumption because the carrier itself, consumes a lot of energy, but really doesn't add anything to the audio. So I would say, yeah, we're generally, in the mid 70s. But if you add MDCL, uh, with a good audio processor, it can be far lower. We have a station at Town Square that uses MDCL, and he's running an older Optimod 9100 on a 2.5, and his transmitter site energy bill dropped by 36%. Now, that's the entire site. So keep in mind, he's still running cooling, he's still running tower lights. It's a 2.5 kilowatt station that runs low power at night. So I'm thinking with MDCL, he probably cut his power, in the transmitter probably by half. Um,
Interesting. Very
yeah.
interesting. Very good.
And that box, by the way, will work with any existing, not only BE AM transmitter, but depending upon the vintage, any more recent Harris or Nautel AM transmitters it can interface with.
Thank you. Appreciate that. Harold?
Yeah, sorry to dominate the conversation here. MDCL is interesting. I've only read about it. I've not experienced it. I'm guessing so the carrier level is reduced what during quiet periods or
Oh,
during loud periods?
yeah, so that's a good question, Harold. So they're actually, so this was developed a lot of work done by the BBC back in the 80s. And internationally, we deployed this in a lot of places outside of the US, newer here. So there are two, I guess I'll call them algorithms. Uh, and I and they're exactly the two methods you talked about. So one, which I think is ADM, uh, that one says uh, when the station audio is low, I lower the carrier. The other one, which is more popular, ACC, uh, says when the station modulation is high, I lower the carrier. So today, generally with the very dense audio that we have, um, it lowers the carrier quite a bit. And so you can set it anywhere from, I think, half a dB to 6 dB reduction in the carrier. And there's a recovery time. So it samples the audio, and depending upon the audio level and density, it determines how fast and how far you go down to that 6 dB level. And then when the audio level reduces, there's another recovery time, much like an audio processor, where the carrier comes back up. So, depending upon your programming, if you're running a lot of music on it and it's pretty dense, the carrier can be depressed an awful lot of the time. If you're on a talk format, again, depending upon how densely you process, it may be less so. But yeah, so there are these two curves. But in the United States, almost everybody runs the curve, which is I reduce the carrier at high levels of modulation.
Of course, the sidebands go down too. So how is that different than just running half power or quarter power if you're densely modulated?
Uh, well, I mean, it is a bit dynamic in that, in theory, is I have quieter passages, it's adaptively changing it. Whereas if I just went to one of those power levels, what would happen in my fringe coverage is as I had quieter passages, because even if I'm running really dense audio all the time, I would have quieter passages at some point, and it would be more noticeable, especially on the fringe. So the power savings difference, if you're really dense, isn't much different than if you just turned the carrier down, Harold. But what does show up is, especially towards the fringe coverage, you're going to get um, more noticeable reception issues during whatever you want to call quiet passages.
Yeah, so the carrier is just a way to keep the receiver quiet when there's not
Yeah,
a lot of
yeah,
audio.
that's exactly, yeah, yeah, and that's exactly right. And so that's why it it provides such a big savings, is that uh even if we make the transmitter super duper efficient, the fact of the matter is about 2/3 of your power consumption is the carrier that doesn't add anything to the modulation. And so if you can start eliminating that or reducing it, I've talked to some guys, the guys at KSL put in a new Orban, audio processor, and I think they told me that their average power is about 12 and a half kilowatts on their 50, and that in their market, they don't really get any listener reports. Now, I'm sure there's somebody DXing it who says that it's a problem. Um, but generally in the market area where you're selling, not a big deal. And we provided some recently to the guys at Odyssey, including one for I think KCBS. And they had indicated that across their group they had very significant energy savings in the millions of dollars a year by running MDCL on a handful of their bigger stations. So it's it's about as close to the free lunch there is for AM stations in power consumption as you can find.
Thank you very much. Great answer. Thank you.
Oh, anyone
Well,
have anything else?
How does reducing transmitter power quiet the receiver? Would seem to
Oh,
me to be just the opposite.
oh no, no. I think maybe we're a little unclear on that. But I think what Harold was saying is the turning it up actually in quiet passages is what helps quiet the receiver. So you're spot on.
Oh, okay.
It's that because it's dynamic. I think the question was, how is this any different than just say I'm turning my transmitter power to half, like 3 dB compression? It's because it's dynamically doing this. So it's kind of saying, well, if I'm really dense audio, I can kind of cheat and turn the carrier down. But when I get to quieter passages, I need to turn it back up or else it's going to get noisy. So you're spot on. That's exactly the phenomenon you would see.
On WOR, you'd swear that modulation was DC.
Well, yes, there are a number of stations where you might confuse that somebody left the mod meter in the RF level setting. But yeah, and well, and that's the thing I would say if you talk about what's changed over time, which was the original point, and you go, wow, why is this such a big deal today when it was invented in the 80s? Well, there's kind of a couple of things. Cost of energy. So one thing to keep in mind is if you think of a network operator like the BBC, they have the same content, even if you set aside FM, they had the same content on a bunch of overlapping transmitters. So generally, when you got to the noisy fringe of one station, you tuned to another station in their network. And especially when you think about the generation of RDS, even for FM, one of the big tasks in Europe is um, you have alternate frequency where it automatically tunes your radio to the next frequency based on the coverage area and information in RDS. So for those guys, turning the carrier down, maybe it made the fringe area a bit noisier, but generally people had already tuned to another frequency. Where in the United States, set aside the FCC regulations, every station's kind of an island with its own programming. And so every station wanted to cover the maximum amount of area it possibly could to get all those listeners. So the idea of turning the carrier down and maybe becoming noisier in the fringe was kind of foreign because there was no other station that you owned that they tuned to that had identical programming. Fast forward to today, power costs are a lot higher. The markets that people are serving, even with a 50 kilowatt, are generally the market they're in, not 38 states. And the advances in audio processors that complement transmitters that can modulate densely, you can get incredibly dense audio, just like you said, Rich, where it can look like a DC meter, but actually still can sound reasonable. You can kind of now afford to turn the carrier down. So that convergence of things kind of made this a lot more applicable today, at least in the US, than when it was invented some time ago.
Well, I really want those 38 states.
Well, it from a listener and DXing standpoint, there's a lot to be said for that. Unfortunately, what most guys find is you're generally not selling any ads and you're only getting credit for the listeners within your, Nielsen market. And so for guys who operate that way, it's a little counterintuitive to us in the engineering side, but it does seem to work.
Well, I've never seen a 50 kilowatt that didn't claim 38 states.
Oh, well, yeah. I mean, let's face it. I think we all draw the biggest possible circle we can and include every community that we think we can claim credit to. It's kind of like, what do they say when you go to the Empire State Building, they claim you can see, I think, 6 states from the top of it. It's like, I don't know, some days you have a hard time seeing 34th Street. So,
We have a comment here about the WLS setup, and he said it was fascinating to watch real time as the carrier level dropped to about 30 to 31 kilowatts during loud voice content, then rise to 50 during pauses. So there's a 40% power saving.
yeah, that's you're describing it really well, Barry, because it's like I think what happens like anything is, look, everybody first gets one of these things and they turn them all the way up, and then somebody goes, "Oh, it doesn't sound quite right," or it's,
Mm.
hey, somebody called and complained. Um, okay, maybe getting 6 dB of carrier reduction, it would be great if you could get away with it. That's maybe where new audio processing helps. But even when you talk about that example, going from 50 to 38 or 35 or 32, whatever your modulation gets you to, man, if I do that for 60% of the day, 24 hours a day, all year, that's a lot of power that I'm saving, and I'm not really giving up anything. Even though maybe it's not the maximum I could get, it it sure helps.
It
The
sure does.
payback is very short. The payback's very short.
And this is one of the reasons I think that stations that had transitioned from tube to solid state, they really need to stop and think about how the modern solid state transmitters will save them more money than perhaps even when they went to solid state in the first place.
Well, for sure, because there is, you know, uh, even additional savings that can be had. I know it's not unique, but I had provided some DX50 transmitters to the CBS stations in New York years ago, and one of them went from the Continental tube rig, and I think the other one was an MW50. And literally after they installed them, the power company came out and changed the meter not once but twice because they were convinced that the meter had gone defective,
Mm.
despite my engineering friends explaining to them and putting a clamp on an ammeter and showing them what the transmitter was consuming. The power consumption was substantially different. So you're spot on that these kind of step level changes in technology, even though you have a perfectly reliable solution, you may actually be able to save money on the power bill. And again, it's a little bit like a free lunch because you're not really having to give up anything.
Yeah. Well, I sure appreciate we've passed an hour here a little bit, and you may have things you need to get to, but would you like to put your contact information back up and
Yeah, sure.
just to close with that?
Yeah, by all means, look, if anyone needs anything from Broadcast Electronics, we're where we've always been in Quincy, Illinois. And so, you can contact us via the website. There's, email links. You can, call. We answer the phone. And whether you need support on an existing box or, want to buy a Marty STL, if you're still doing RF STLs, or, you need studio products, everyone's around to help you out. And look, we really appreciate the opportunity to participate. uh, it's always nice to have a dialogue here that honestly challenges me a little bit technically and get to talk about stuff that I don't always get to talk about every day.
Well, between the Zoom and the live on YouTube, we've got about 50 some folks here. And Eric, you have something to add?
I just have a question on the adjustment of the carrier level, and I'm not in the business anymore, so I wouldn't have had the opportunity to test this. But if your transmitter carrier power is adjusting dynamically for power saving reasons that sound really good, has anybody noticed any change in behavior in the receivers that might be using either the seek mode or the scan mode? Is it possible that they may not stop when they go by your station if the carrier has been depressed some?
Yeah, that's a good question. I will be honest and say I don't know the technical answer to that. What I can say is when the FCC authorized this, and I'm wanting to say, I don't know, Barry, was that around 2010? Somewhere around that time frame, maybe.
Yeah, when the commission.
MDCL was authorized.
Correct.
There was a significant amount of field testing done, both to the impact on the transmitter, but then also, drive testing and so forth on receivers. And my recollection was that, the general comments were if you're generally in areas of decent reception, it's pretty invisible. If you're at areas on the fringe, as we've talked about, you may notice a little bit more fuzzy reception. And I would think, to your question, that probably does indeed impact scan. But generally, if you're in the market, uh, you know, there's not a lot of impact, it seems.
Yeah, I mean, most people aren't usually doing seek or scan anyway. I just when you started talking about it, I was in the satellite business at the time, so I wasn't paying attention to the industry talk, and it's like, I wonder if that affects it or not. And
Yeah,
it's like it could be one of those things that it has an effect, but uh, uh, it's not real for the business, so
yeah,
it's
there
not real.
probably is some, like anything, there's probably always some impact. I do think as time goes on and the radios have gotten a lot better, it's kind of like the current debate about, do we still need to protect to 10.7 IF and FM that doesn't really exist anymore? And, some of these other uh, things that as the radios got better and better, became less of an issue. Uh, yeah, and that most listings in cars, and so that cars generally have much newer receivers than 20-year-old tabletops or tuners. Um, but I would say the general point was that yes, there always were a few comments, generally not very many, and almost all the times the comments were either from, I guess I would say, super technically inclined listeners that were, I'm not saying they're just DXers, but were more of that kind than they were, Susie Homemaker, who listens to the midday show, said, "Hey, somehow when I press the button, I seem to skip over you guys anymore, or I can't get you at my house." My recollection was the feedback didn't seem to be that so much. It was more kind of very specific kinds of listeners.
Be interesting.
Again, thanks everyone. And should you have any needs, we're happy to help out. And Barry, we're always happy to support and try to cover topics. And look, while for sure we talk about the stuff that we make, we also try to talk about this in just general technology terms. A lot of the things that I mentioned on RF devices and power supplies, are pretty applicable across the industry. We think our implementation's the best, but pretty much, all of us take advantage of the same RF devices and power supplies suppliers. So the good news is, as engineers, we just have access to a lot better stuff generally than we did 10, 15, 20 years ago. So
Quite so.
it's good news, I think.
Rich, thank you so very much.
Hey, thanks everyone for the opportunity today. We really appreciate it.
We'll see you soon.
Thanks.